Assalamualaikum warahmatullahi wabarakatuh, and very good day to all the panelists and supervisor. First of all, I would like to introduce myself. My name is Muhammad Hakim bin Bakeri. My title for FYP Project is Investigation of Vertex Joints using Non-Structural Mass. My FYP project is under supervision of Associate Professor IR Dr. Muhammad Azmi, Yunus, and my co-supervisor is Dr. Muhammad Norhisham Rani. I would like to greet my panelists for this FYP presentation, Dr. Muhammad Nur Azmi bin Abdul Patar and Dr. Hafizan Hashim. Let's move on to the next agenda. Okay, today I would like to present the content of my FYP proposal presentation. I would like to present project background, objective, problem statement, scope and limitation of the project, literature review, methodology, expected result, and project planning. We move on to the first content, project background. For the project background, the title of this project is the investigation of vertex joint using non-structural mass. Vertex joint, as we know, is an element of connection that widely used in numerous applications, especially in engineering. We can see all these types of vertex joint in every aspect that we find in machine, design, and rotating equipment. To study vertex joint is very exciting. The aim of this study is to analyze the dynamic behavior and vibration of the model. Before I would like to proceed for the next point, I would like to add some point. What is non-structural mass? If you wonder, non-structural mass is a process where the mass is added to the element without changing its stiffness. Numerous ways of finite element analysis (FEA) will be implemented for this investigation by applying non-structural mass parameters. So this paper will outline the difference in approach when conducting the experimental and simulation work. For the objective, there are three main objectives that I would like to explain for this presentation. First objective is to model and simulate vertex joint in the finite element method using the non-structural mass NSM technique. Second objective is to identify the dynamic behavior of the vertex joint using experimental model analysis, also known as EMA. The third point is to validate the dynamic behavior of the vertex joint between finite element experimental model analysis result. For the next slide, I would like to explain about the problem statement. There are few problems that will occur during the process of the research. The first problem that I identified during the process of research this project is the assembly process may have circumstances due to the analytical model that does not apply to this vertex joint. The difference in geometry and the external forces is not symmetry to the interface. That's one of the problems that I face for current time or time being. For the second point of the problem statement is the non-structural mass or NSM. This process requires smaller mesh elements and also will impact the compute time, which the calculation will be longer. But if we can solve this kind of problem, the result that we achieve may be more precise and accurate. The third problem that I identify is to improve the model correlation of the finite element model. For the next slide, I will explain about the scope and limitation of the project. The analysis of this project is based on the bolted joint structure only. The element connector that will be used for this project when modeling of the bolted joint structure are RBE2, C-bar, and C-beam. The project will be conducted, or simulation will be conducted in non-structural mass NSN parameter, and the condition that will be applied is free frame boundary condition. From that parameter of will be estimated, the result will be carried out through the frequency. The range of frequency that will be interested in ranging from 0 Hz to 1000 Hz. The approach that we use for this type of project is linear analysis. Linear analysis of the natural frequency and mode shape parameter will be obtained. We will only interested for the first 10 elastic mode for this project. For the literature review, there are some few critical points that I highlight for this slide. First point is every structural modeling was performed to acquire the value of the natural frequency and mode shape. The software that usually used for this structural analysis is Altair HyperWorks or MSc Nasran. But at the end of this semester, I identified that the software that suits with me is MSc Nasran because the software is very well integrated and user-friendly. Third point of the literature review is the element connector that researchers always apply are rigid connection element or RBE2, connector element C-bar and C-beam, and spring element C-las and C-bush. But for my scope, I only focus on RBE2, C-bar, and C-beam. Another research that I found out from this literature review is the FRF or frequency response function is so-called the relationship between the response and excitation at various locations. It is the initial step to measure the structure, excitation, and response. During this process, the finite element model will be imported from CAD drawing, any CAD drawing like CATIA or AutoCAD in IDS file to import to CAE software like MSc Nasran when performing the model testing or analysis. The dynamic behavior of the bolted joint structure will be identified and analyzed for this project. Okay, for the methodology, I will explain. First, we need to identify what kind of structure that will be implemented for this project. So, for this project, we will use bolted joint structure. There are two approaches that will be used. First, experimental model analysis or EMA, and then after we perform EMA, the model testing will be performed. From that testing, we can obtain the result extraction, and then after that we validate by MSc validation. The second approach that will be used for this project is FEA or finite element analysis. But after we proceed with FEA, RBE2 and C-bar and C-beam, the element connector of the structure will be applied for this whole process. By performing this finite element analysis, the result will be extracted. After the extraction occur, we need to validate, and then the end. As you can see from the slide, that is the CAD diagram for the FYP project that will be analyzed. The material properties for the shape that will be used have two types. First start is for U-shape. The U-shape will be used aluminum T606-134. Okay. Young modulus of 69 gigapascal and Poisson ratio 0.3 with the mass density of 2,700 and with mass density of 2,700 kilogram per meter cube. For the plate, will be used on steel with young modulus of 210 gigapascal with Poisson ratio of 0.3. The density of this my steel is 7,850 kilogram per meter cube. And for the expected result, what we expect from this project is with different element character that will be implemented, it will provide different natural frequency and mode shape. And second expected result, the result will be almost identical or higher accuracy with the finite element method. The third expected result is one of the element connector will better correlate natural frequency and mode shape. So this is my project. Planning for FYP 1 and FYP 2. Overall, the planning is according to the plan. That's all from me. Thank you. If you have any question to ask, please feel free to ask me. You can contact me on the email below. Thank you. Bye. Assalamualaikum.